right, everybody, section 5.4, theoretical and percent yield. Theoretical yield is the maximum amount of product that can be formed from a reaction based on the amounts of the reactants. So it's kind of in theory, this much could be produced given this much. The actual yield, in contrast, is what is actually obtained. So there's kind of a design and an expectation, but then you have to compare that to what you actually get. So the percent yield is defined as 100% times the ratio of the actual to the theoretical yield. So here we have 12 grams of CO2 reacts with 8 grams of H2O to give 7.5 grams of C6H12O6. Determine the percent yield of glucose from this reaction. Oof, where do we even start? We're given 3 amounts: CO2 amount, H2O amount, and C6H12O6 amount. It's kind of crazy. Well, this is something that you know how to do. And this is actually integrating what you did in the last segment. What you're going to do is you're going to convert these masses, 12 grams CO2, to the amounts. Or sorry, you're going to convert these masses to the number of moles so that you can figure out the molar mass of all of these, so that you can figure out the limiting reactant. So the molar mass of CO2 is 44.01 grams. Okay, and that will give me 1 mole of CO2. Now what I want to do is I want to relate this to my number of moles of a product, C6H12O6. Okay, so what I'm going to do though is I'm just going to go ahead and extend this all the way to get my mass of C6H12O6, because when I get that, then I have my theoretical yield. Okay, so 1 mole, my balanced chemical reaction says 6 moles of CO2 produce 1 mole of C6H12O6. My molar mass of C6H12O6 has a mass of 180.16 grams. Plug all that in. 12 times 180.16 divided by 12 times 180.16 divided by parentheses 44.01 times 6 close parentheses equals 8.18 grams of C6H12O6. Okay, now is this the number that I'm going to use? I don't know. What I do need to know though is basically, is this amount lower than the amount with my other option? My other option is 8 grams H2O. I'm going to set this up the exact same way. 18.02 grams of H2O will give me 1 mole of H2O. Now, 6 moles of H2O gives me 1 mole C6H12O6. Okay, now 1 mole of C6H12O6 has a mass of 180.16 grams equals, so 8 times 180.16 divided by parentheses 18.02 times 6 equals 13.3 grams of C6H12O6. Okay, so now with this number, with these two numbers, well, effectively what I'm trying to do is figure out, is it CO2 or is it H2O that's my limiting reactant? I did add this extra step right here, where I'm converting my moles of C6H12O6 into a mass. And so what I can do is I can say, well, which one of these would produce less? That is my limiting reactant. Now, the point of this question is not primarily to find out the limiting reactant, but instead it's to find out the percent yield. So now that we have the limiting now that we have basically the limiting reactant and the amount that produces, we can compare our actual yield, 7.50 grams of C6H12O6 to 8.18 grams of C6H12O6. This is our actual yield because this is what we were given in the problem. This is our theoretical yield based on our limiting reactant. We can multiply this by 100 and we find out that looks like it's about 80% or so. 7.5 divided by 8.18. No, I'm off. It's about 91.6%. Okay, I hope that was helpful. And this is really this calculation is a simple one. Everything that we've done up until now was the tough stuff. So if you're struggling with this, I would argue that's fine. It's not awesome that you're struggling, but that's fine because you've already done the tough stuff. This is one last simple step that you need to throw on to the end. Hope this was helpful, and we'll proceed on with the next section of Chapter 5.